All right, hello, welcome. This is a tutorial for trigonometry for grade 11s coming into grade 11 senior sciences for physics, chemistry, AP physics, biology, you may need it, environmental sciences. So I'm going to do a quick tutorial. This is Mr. Doig, and you would have got training through math, hopefully math 10. Some of you may have already taken math 11, in fact. So some of this may be reviews, and I hope that it is. And we're going to focus in on Pythagorean theorem. We're going to look at SOHCAHTOA, and we're going to do some examples here. Mr. Wilkie has provided you all with a review and practice sheet on algebra and trigonometry, and this should help you, hopefully. All right, so here we go. First off, we're just going to draw right-angled triangles. We're going to deal with right-angled triangles today only. And my first right-angled triangle is this. And it's a right-angled triangle with three sides, obviously. And I am going to call this angle at the bottom theta. And so for those who remember, Pythagorean theorem will state that c squared is equal to a squared plus b squared. Therefore, c is equal to the square root of a squared plus b squared. All right? Remember, c does not equal a plus b. You can't take just the square root of a and the square root of b. You have to take everything under that bracket. It's all under 1, so c equals the square root of a squared plus b squared. Now, from the angle standpoint, we have that angle theta, and we can do a lot of things with angle theta. So, for example, from your review in math, we know that the sine of angle theta is equal to the opposite from the angle over the hypotenuse of the triangle. So in this case, the opposite from angle theta is the letter A, side A, and the hypotenuse is side C. All right, so that's the whole SO of the SOHCAHTOA. Cosine of the angle theta is the adjacent side, divided by the hypotenuse. All right, so, and in this case, the adjacent side is side B, and the hypotenuse is still C. So in that case, we get the CA, the C, the cos, the adjacent, and the hypotenuse. There's the combination of the CA. And the last one we can look at is the angle for the tangent of that angle, and that is equal to the opposite over the adjacent side. All right, so here we go. And in this case, the opposite side, again, is A from that angle, and the opposite and the adjacent side is B. So in this case, you get the TOA, the tan, and the opposite and adjacent. All right, so that's just a bit of a review from grade 10 trigonometry. And let's just do an example of it so that we're not just putting down words and letters for you in this case. All right, so I'm just going to scroll up, and we'll get our first of our three examples here today. Example number 1. All right, so in physics we do a lot of things with ramps and understanding how to use our trigonometry in these problems. So for example, say I had a ramp, and here's a ramp here, green for those in Lonsdale, so that's more Lakes green. There's the ramp there. Now I don't know the length of this ramp, all right, so I don't know the length of this ramp. Ramp runs this way. Now what I do know, however, is that the height of that ramp on the wall that it is attached to is 3 meters high. And I also know that the ramp itself is, the bottom of the ramp is 10 meters away from the wall. So I know that there's a nice right angle triangle here that's formed, and so I want to find some things out. First off, I want to figure out the angle at which that ramp is at. So let's do that first. Let's find the angle. So first part of this is let's find theta. All right, I'm telling a story here. I'm writing down what I know and what I can figure out using the trigonometry I have. Now, the only two sides that I do know are 3 meters and 10 meters, and those happen to be the sides that make the right angle. And 3 is opposite angle theta, and 10 is adjacent to angle theta. So if I look up above, opposite and adjacent, I'm going to use, all right, and I'm going to say using a TOA. So I'm going to use the tangent tool here, and I'm going to say, oh, okay, cool. Tangent of theta is equal to 3 meters divided by 10 meters. Well, the meters cancel out, And theta, if you remember your grade 10 trigonometry, then equals to the inverse tangent, or arctan, but the inverse tangent of 3 divided by 10. And in this case, the angle theta is 16.69 degrees. All right. So there's our answer. That's the angle that the ramp makes with the floor. All right, or I call the horizontal, that 10-meter segment of that triangle. So that was the first part of the example. Now I want to find the length of that. Well, there's a couple of ways we could do that. Now that we know the angle, we could use some trigonometry, but I could just use Pythagorean theorem, right? So L is the hypotenuse. So what I can say here is that L is equal to the square root of 3 squared plus 10 squared. So that equals to the square root of 9 plus 100. And so L is equal to the square root of 109, which is equal to 10.44 meters. So I have a 10.44 meter length of ramp that we can then use in the physics of it. I don't know, we push a box up it, or we attach pulleys, or whatever it might be. But this is the way in which you can then solve some of these things, that green length of the ramp, supported by 3 meter and 10 meter sides of that along that triangle. Okay, so there's an example of using tangent to find the angle and using Pythagorean theorem to help find the length of the ramp. That should be a nice little review for you from grade 10 math. All right, here's another example coming at you. And I'll do this one in, I don't know, case purple. All right, here we go. So we have an example here. So I'm going to draw another right angle triangle. And what I'm going to say is this, is that the right angle triangle is like, sorry, I'm just making sure I get everything right here. So I have here my right angle triangle. And I'm going to say that this angle theta 1 is equal to 55 degrees. Now, I have no idea how long this segment here is, and I don't know what this distance here is. So we're kind of going on the whole ramp premise that we did before. What I do know is that's going to be a right angle triangle, and I'm going to say that this ramp, in this case, along the wall. Ramp makes an angle of 55 degrees with that vertical segment, that 4-meter segment. So let's figure out here, let's figure out what theta 2 is, figure out what the length of the ramp is, and let's figure out how far away the bottom of that ramp is from the wall, otherwise known as D in there. All right, so what I'm going to do first step, I'm going to find the length of this ramp in this case. I'm going to find L, length of the ramp. And what I do know is that in this case, I'll redraw this triangle just to simplify it. I know that that's 4 meters, that is 55 degrees, and I'm trying to find L right there. All right, so I can look at that and say, okay, I have an angle, I have a side, the side is adjacent to that angle, ooh, adjacent, so I'm going to use using the tool, the cosine tool. All right, so what I can say is that the cosine of 55 degrees should equal to the adjacent side, which is 4 meters, over the hypotenuse L. All right, and so if I rearrange that, put the L up and the cosine 55 whole thing down, I'm going to say that this is 4 meters divided by a cosine of 55 degrees. And so the length of this ramp is 6.97 meters. All right, so that's the length of the ramp right there. So we found the length of the ramp. Now what I'm going to say, well, let's find how far away the ramp is from the wall. Let's find D. Let's find the bottom of the ramp. How far is that away from the wall? I'm going to say, okay, I'm going to do this 2 ways. I'm going to say, first off, I'm going to find D, all right? And I'm going to use Pythagorean theorem. So I'm going to use the Pythagorean theorem to theorem. How about I spell that correctly? Sorry, theorem. And so let's do that. We're going to say, oh, cool. Okay, well, D is not the hypotenuse, but it is equal to, if we rearrange, maybe I'll start here and say, I know that L squared is equal to D squared plus 4 squared. So that's just the the Pythagorean theorem with L being the hypotenuse. Now rearrange that and we get the L squared minus 4 squared. All right, so D squared equals L squared minus 4 squared. And so D is equal to the square root of L squared minus 4 squared. And what did we get for L? Well, we had L up here, it was 6.97 minus 4 squared, which is equal to, let's see, I'm going to do the math here. So 48.63 minus 16. And so therefore, bring this all back into here. So D is equal to the square root of 32.63, which is equal to 5.71 meters. All right. Well, we could have used some trig as well in this to find D, and let's just check our answer. The beauty of all this is that we can actually check our answer, right? So what we have here is that in the third way, we can find D just to check. So if I redraw that triangle, what we had was this, had 4, had 55 degrees, right? And D is here, unknown. Well, what we do know is that tangent of 5 degrees in this case would equal to D divided by, so that's 4 meters. And so D, rearrange that 4 meters times tangent of 55 degrees, plug that into your calculator, and you'll see, that's pretty cool. Still equals 5.71 meters. Nice. So we got the same answer. Okay, so 2 different tools. You can figure out what you can use, you can choose. All right, use what you want to choose what you want to use. All right, so now what we're going to go is the last step in this. I asked you to find out this angle here. I'm going to put here a theta 2. All right, so what is theta 2? Well, using my geometry knowledge, I know that all the interior angles of a triangle, this is a right angle triangle, we can add up to 180 degrees. So if I redraw this triangle and say, okay, there's 90, there's 55, this is theta 2, what the heck is that? Well, what I can say is that theta 2 is going to equal to 180 minus 55 plus 90. Okay, so what does that equal to? Well, that's 180 minus 145, and we get a nice 35-degree angle here for theta 2. Now, you could also do some trig on that if you really wanted to do that, and you can say, oh, okay, well, I also know that this length here is 4 meters. I just calculated that that's 5.71 meters, and what I can say is, or I can look at another way to do this and say that, oh, okay, tan of theta 2 is equal to 4 meters divided by 5.71 meters, all right, and so I cross that out. I take the inverse tan of that, and I say, oh, okay, the inverse tan of 4 divided by 5.71, and what do you get? You get 35 degrees. Voila, all right? They check out, which is really good. Okay, so there's some good examples. The third example that I'm going to run right now is sort of a precursor, or maybe just a heads up as to what we're going to get into, especially in physics. You guys are going to look at and deal with components, and what that means is that any line can be resolved into an x and a y component. So for example, if I drew this triangle here, let's see, what color am I going to do today? I'll do kind of a Ripley's blue. Let's see how that will go. And say I do any line. So say I do a line like this, and I say, okay, this line is going to be, what is it going to be? I'm going to say that this one here is like that. All right, and this line, what I can say is that maybe someone applied a force in this direction, and it makes an angle with the flat horizontal of this theta. All right, and we're going to say perhaps that it makes an angle of 21 degrees with the horizontal there. So there's a force, because you can imagine someone pushing something with a force in that direction. And what we can say is that this force can actually be resolved into an x component, this dotted line here. So this is a force, and say we apply 37 newtons of force along that, in that direction. Notice I put little arrowheads showing the direction there. and it's 21 degrees above that flat horizontal line. Now, what I'm doing is I'm breaking this, this vector, as we call it, and this is our example 3, sorry. We break that vector into an x component. So this is the force in the x direction. This dotted line, this light blue dotted line moving to the right. And what I can show here is that this purple line or pink fuchsia line going up, this is the component in the y direction. You know, it's not a flat line. The 37 Newton line is not directly horizontal, nor is it directly vertical. It's 21 degrees above the vertical, so it has a portion of it that can be broken down in the x direction called f of x, and it has a portion that we can say is also broken down in the y direction called f of y. So there's two components, and these make a nice right angle triangle there. And so these fy and f of x component, we want to figure out how big they are, and we can use our trigonometry in this way as well. So what we can do is to say, okay, well, I want to find, right, here's the problem, find the f of y, and please also find the f of x. Okay, so find f of x. So that's the problem. Okay, so first step, let's do this. Okay. Well, for finding f of x, let's look at f of x here. What do I know? I know that I have a hypotenuse, it's 37 newtons long, and there's an angle there of 21 degrees. And f of x is adjacent to that angle of 21 degrees. And so, okay, so if I know that, I can say, well, I know that cosine of angles, this basically equals to the adjacent side over the hypotenuse, correct? All right, so that's what we talked about. That's the CA, right? That's the CA that we learned in grade 10. So what I can say is truly that the cosine of this angle theta, which is 21 degrees, is going to equal to f of x over the long hypotenuse, simply labeled as f. Okay, we'll find f of x. Rearrange that. Take that f off the bottom, chuck it up top, so I can say that f times cosine of theta is going to equal f of x. That's pretty cool. I know how to do all that. What is f's value? F's value is 37 newtons. What's cosine value? 21 degrees. All right, so the length of that x component, the f of x component, is going to be 34.54 newtons. That's how long that x component of that force is. Now I'm going to do the same thing for the y component. I'll do it in pink, actually, because that's, or fuchsia perhaps is the right name for that color. And let's find f of y. Notice I'm using the titles and I'm using all my formula and I'm showing all my work. That's crucial. If you're not doing this in your review package that you get from Mr. Wilkie, please redo that. Please show us all your work at all times, formulas and everything. Follow this tutorial and you can see how I'm using my formulas and then plugging in numbers at the end. All right, so f of y, we're going to follow the same sort of logic here. I'm going to say that the sine of angle theta, I know that is equal to the opposite over the hypotenuse. That's the SO, right? There's the SO tool that we can use. So what we say is that sine of theta is then equal to f of y, that's the opposite from the 21 degrees, over the f. Okay, rearrange that again, just as we did before. All right, so f times sine theta is going to equal the y component. Notice the y component is going to be much shorter than the x component. This isn't a very steep angle. It's only 21 degrees, so there isn't a huge amount pointing upward in the vertical of that 37 Newton force. Most of that 37 Newton force is directly horizontal, but it has a bit of y component in it, so it pushes it up, and we get this nice right angle triangle that we're looking at. And as a result, what do we have? 37 newtons times the sine of 21 degrees. All right, and so how long is that that y component? That y component is 13.26 newtons. And there you have it. That's your first little lesson on components using your trigonometry and your knowledge on how to use SO and CA. All right. I'm going to leave that there. You have some problems that you can then attack with Mr. Wilkie's review package. Please show all your work. Don't just write down answers and don't just write down numbers. Just notice how we've always written down formula throughout this entire tutorial. Thank you very much, and we will see you all in September. Ciao.